Okay, so let's look at the next question. So the next question asks us to draw out each step of beta oxidation. So beta oxidation is also really important. Dr. Thomas did say that you guys will most likely have to draw this on your exam. It doesn't really matter what type of fatty acid he gives you, as long as it's a chain. They all have different names depending on the amount of carbons that they have. So let's first begin by defining what beta oxidation is. So it's a catabolic process by which fatty acid molecules are broken down in cytosol to generate acetyl-CoA. And this right here is the important part, generating acetyl-CoA. And so for every round of beta oxidation, I'm just going to put this in the corner. So each round, through this entire process that we'll go over, you produce one FADH2, one NADH, and one CoA. Something to keep note of is the last round of beta oxidation will actually not generate a fatty acid in which you can keep going, because there's only so many breakdowns of the fatty acid you can go through. Finally, you'll just generate 2 acetyl-CoAs because you can't break it down anymore. So instead of having, in this case, 1 fatty acid plus 1 acetyl-CoA, here you just generate 2 acetyl-CoA once you cleave them. So let's go through this and see how this process works. So let's start off with, let's look at palmitol CoA. So as you'll notice too, this fatty acid has already gone through the process of linking it to a coenzyme A. Beta oxidation cannot occur until the fatty acid has been linked to the enzyme. So let me just draw the structure. And then the high energy bond that's here. So looking at, oh, sorry, I forgot the double bond. Looking at the carbonyl group here, I also forgot a carbon here. We're going to be counting to the left, and that'll start our alpha beta carbons. And these are the carbons that we'll be looking at. Specifically, we are looking at this region right here. So the first step in beta oxidation is you have dehydrogenase. So you have acyl, CoA, right? Because you have the acyl group, CoA. They're usually always named in their precursor. And this is dehydrogenase. I emphasize this a lot in my sessions, but anytime you have dehydrogenase enzyme, you have a redox reaction. So it means that something's going to get reduced, something's going to get oxidized. And in this case, you're inserting FAD, and FAD is actually getting reduced to FADH2. And, you know, as we looked at the product of each beta oxidation, this is actually where we produce our FADH. So as this is getting reduced, our chain of fatty acid is getting oxidized. So we get our R group, and then we have our oxidation, which is here, and then our acyl-CoA. So the double bond is actually occurring between the alpha and the beta group. And this is where the oxidation is. So we have reduction here and oxidation here. Okay, so now this is called trans-enol-CoA. There's a delta 2 because at the 1, 2 position is where we have, it's 1, 2, 3. At the second position is where we see that double bond. Okay, so because this will go into a later discussion, but because we are in the trans form here, we can proceed with the oxidation. So then we go into the next step, which is using enol-CoA hydratase. And anytime we have that type of enzyme, we are adding in water. So our product looks like this. Okay, so we still have our, this is in different color. So we still have this group that's here, except now we have OH and H. So where is the water now? It's where this hydrogen is, OH, and then where the second hydrogen came in. So we broke this bond right here, and we added water to this OH and this H. Okay, so this is called L-beta hydroxy acyl-CoA. Okay? Okay, so now we are going into, we're almost done here. I might actually need more room, but I can make this work. Okay, so the next step is we add beta hydroxy acyl-CoA dehydrogenase. Again, anytime we have dehydrogenase, we have some type of redox reaction. Instead, we don't have FAD, but we have NAD+. So NAD+ is forming NADH. And this is where reduction occurs. Therefore, we know that our chain of fatty acid is going to get oxidized. So we have our R group, so again, we're looking at the same position here. And instead, what happened is this specific group, the previous group that I'm boxing right here, just got oxidized into a carbonyl. So this is where the oxidation occurs. Okay? And this is called beta keto-acyl-CoA. So now, in the final step is when we add our coenzyme with a thioester bond, and that gives us our fatty acid cleavage, CoA. So this right here is our fatty acid. But now we have an addition of the acetyl-CoA. And this bond right here is the same ones that I've been highlighting so I can follow along and show you guys where it is. So this is the acetyl-CoA. Now, this doesn't stop here. So this fatty acid can actually go through another round. So now we have our major product and our minor product, which can go through this process again.